Hi guys, so today we're going to finish up a system of linear inequalities, and this time we're going to be talking about word problems. Okay, so there are actually many situations that arise in business and engineering that necessitate or require systems of linear inequalities. Okay? The region in the xy plane, that just means our graph here, okay, that solves the systems often represents all of the viable solutions, right? So we've seen that previously when we were graphing, right, that our solution to a system is all possible answers, right? It represents everything that makes the system true, okay, for every inequality. So being able to visualize or graph this region is extremely helpful, because all we need to do is make sure that whatever we're talking about is within that shaded region that completely overlaps, okay? So we're going to look at a couple of word problems here to see this. Okay. So this is the first word problem. Frank is going shopping for wrapping paper and bows. Okay. We know that he needs at least one bow, and he has a total of $3 to spend. Wrapping paper costs 25 cents, and bows cost $1. We're going to write a system of linear inequalities to show how many rolls of wrapping paper and how many bows Frank can buy. Okay, and then we're going to graph it here. So as always, we're going to start by defining our variable. Okay, and the tip is to look at what our question is asking for, right? So here we want to know how many rolls of wrapping paper and how many bows Frank can buy. Okay, so I'm going to make X here the number of bows. Okay, and I'm going to make Y here the number of rolls of wrapping paper. Okay. Like I said previously when we did systems, okay, for these types of word problems, it really doesn't matter which one is our X and Y, right? So someone could have done X as rolls of wrapping paper, and then someone could have done Y as number of bows, and that's fine. Okay. The only difference is then you have to match up the correct numbers with whichever letter you choose to use. Okay. So now we're going to write our inequality. Okay, so we're going to look at types of totals and things like that, right? So here, right, I know that he needs at least one bow. Okay, so this is a total here, right? So he needs at least one bow. Okay, and then the other thing I know is that he has a total of $3 to spend. Okay, this is my other total. So as I'm creating this inequality, I should probably be looking at how much things cost, right? And we see that here, right, that wrapping papers cost 25 cents and bows cost $1. Okay? So that's probably, all the cost stuff is probably going to be in one inequality. Okay? So here, I know that he needs at least one bow, and since X represents the number of bows, that means the number of bows has to be greater than or equal to 1, right? Because he needs at least 1, so X is greater than or equal to 1. Okay. If you had written them as flipped, right? If this was X and this was Y, then instead you would have Y greater than or equal to 1, right? So the inequality that you write just has to match the variable that you're defining. Okay. Then the other inequality I'm going to write is for cost, right? So we know that he has a total of $3 to spend. You cannot spend more than you have, or else you'll be in debt, right? So however much he spends has to be less than or equal to $3. Okay. So what is he spending money on? Okay. So we know he's spending money on bows and wrapping paper. Okay. So I'm going to do bows first since that was my X, right? So since each bow costs $1, 1x represents how much he'll spend on bows, right? So if he spends if he buys one bow, it'll be 1 times 1. If he has 2 bows, then he'll spend $2 total, so on and so forth, right? So this gives me the total of money he spends on bows. Okay. Then since it's 25 cents for wrapping paper, and wrapping paper is Y, okay, it's going to plus 0.25y. Okay. this here, the 0.25y, represents how much he'll spend on wrapping paper, right? So if he has one wrapping paper, that's 25 cents. Two, that's 25 cents times two, so 50 cents, so on and so forth, right? And the total money spent on bows here, the total money spent here on wrapping paper has to be less than or equal to the $3 he has. Okay. So now I'm going to graph. Okay. Since x is the number of bows, I'm going to label my x-axis here bows. Right? Or technically you can even label it down here. Okay. And then y is going to be wrapping paper, so wrapping paper. Okay. Or you can even label it on the side here, wrapping paper. Okay. So I'm going to graph using intercepts. Okay, so I'm going to find my x-intercept first to help me graph it. Okay. So x-intercept, I plug in 0 for y. So here I'm going to plug in 0 for y less than or equal to 3. Okay, so then that just means x is less than or equal to 3. So my y-intercept here is going to be 3, 0. Okay. Okay. So 3 because of this, and then 0, I plug that in for y. Okay, so for my y-intercept, I'm going to plug in 0 this time for x. Okay. So this is gone. 1 times 0 is nothing. Okay, so I have 0.25y less than or equal to 3. If I divide by 0.25, I get y less than or equal to 12. So this means my y-intercept is 0, 12. Okay. So I'm going to now label it. Since I need it to all the way hit 12, I'm going to label this by 2s. So this is 2, 4, 6, 8, 10, 12. Okay, and just to make it to scale, I'm going to also go 2, 4, 6, 8, 10, 12 as well. Okay. So x is greater than or equal to 1. Okay, so this is going to be a vertical line. Okay. Arrows in the end. Okay, technically I don't even have to graph up to here because you can't have negative wrapping paper, right? Okay, and then since I want greater than, so the x's that are greater than are going to be to the right. Okay. I'm not going to keep going since there can't be negative. Okay. Then for my y-intercept, 3, 0, so that's here. 0, 12, that's here. Okay. Then connect the dots here. Okay. Technically, I don't have to keep going because, like I said, you can't have negative bows or negative wrapping paper, so it's all going to be in this first quadrant. Okay. And since it's the less than, I want to shade below. Okay. So the section of the graph that I want, where it all points to, is this tiny, tiny sliver right here. Okay, so any combination of bows and wrapping papers within this small little shaded region, okay, will meet the requirements for this inequality. Okay, so now let's move on to the next one. Okay, so Michael is on a budget for the remaining items for his daughter's birthday party, where he can spend at most $50. He plans on buying decorations where the balloon costs $2 each, and the favors cost $5 each. He intends to buy less than 30 items. We're just going to write a system of linear inequalities to represent it, so this time we're not going to graph it. Okay, so let's chunk out what we have. Okay, so let's look at totals. Okay, so on a budget, we know he can spend at most $50. So this is a total. Okay. So since this is talking about money, right, I need to see what he's going to spend money on. Okay, so here we find out that he's going to spend money on balloons and favors. We know that balloons cost $2 each and favors cost $5 each. Okay, Then the other total I see is that he intends to buy less than 30 items. So that's another total. Okay. So now we're going to write a system of linear inequalities to represent this situation. So I'm going to start with my variables, right? So X, I'm going to make it the number of balloons. Okay. And Y is going to be the number of favors. Okay. So here, I know balloons cost $2 each, so if I do 2x, this is going to represent the money spent on balloons, right? So if he buys one balloon, that's 2 times 1, $2. 2 balloons, that's 2 times 2, $4, right? If he buys 10 balloons, since x is number of balloons, 2 times 10, $20, okay? So on and so forth. Then favors cost $5 each, so since favors is y, 5y is going to give me the amount of money he spends on favors. Okay. Since we know he can spend at most $50, that means whatever he spends money on balloons and favors, has to be less than or equal to 50. Okay. Then, my other total, right, is that he's going to have less than 30 items. So number of balloons, which is x is number of balloons, plus the number of favors, which is y, we know has to be less than 30. Okay. And that is my inequality, right? I could use Desmos to help graph it for me. And anything in the overlapped regions will be the combination of balloons and favors that is less than 30 items and cost less than $50. Okay. So some of you guys have been asking a lot about whether or not the variable matters. No, it does not, right? So here I did x as balloons, y as favors. You can do the opposite, right? You could do x as favors and y as number of balloons. That is fine as well. Okay. Your equation will be similar but slightly different, right? So if x is number of favors, then instead of 5y, right, it'd be 5x, right? Because each favor costs $5, right? If you chose y as your number of balloons, then it'll be 2y to represent how much you spent, right? And the total is still going to be the same. It's still going to be less than 50, right? And then the next equation is actually going to be the same either way, because number of favors, x in this case, plus the number of balloons is going to be less than 30. Right? So it's very similar, right? The only thing you can see is that here it's a little different, right? So instead of 2x 5y, it was 5x 2y. Okay? And then here's our last one. Okay? So here we work 2 jobs. You work 2 jobs for a total of less than 40 hours a week. At your first job, you're paid $10 an hour. And your second job pays you $8 an hour. You need to earn at least $200 to pay your bills. Okay. Write a system of linear inequalities to represent this situation. Okay. So again, right, we're going to look at totals. I'm going to start by defining my variables. Okay. So x is going to represent the number of hours at my first job. Okay. And then y is going to represent the number of hours at the second job. Okay. Again, it doesn't matter. You could have chosen it. You could have flipped it. You could have made this y and this x. It doesn't matter. Your inequality will just look a little different, but both are still okay. Okay. So looking at totals, the first total I know is that both jobs I worked for a total of less than 40 hours a week. Okay. The other total I see is about how much I earn, right? And I need to earn at least $200. Okay. So if I'm talking about earning money, I should probably see how much it pays. Okay. So my first job pays $10 an hour. The second job pays $8 an hour. Okay. And now from here, I'm going to write my inequalities. So if I need to work, if I work less than 40 hours, that means the numbers at my first job, number of hours at my first job, X, plus the number of hours I work at my second job, Y, has to be less than 40. So if X is hours at first job, hours at second job, they total to be less than 40. Then my second inequality, I'm going to use the total of money being earned. Okay. If I need to earn at least $200, that means I need greater than or equal to 200. Okay. My first job pays me $10 an hour. Okay. So if I do 10x, this represents the money I'm paid at my first job, right? If I work 1 hour, since x is number of 1 hour, that's 10 times 1. If I work, let's say, 5 hours, right, that's 10 times 5, $50, so on and so forth. Okay. At my second job, it's $8 an hour, so plus this 8y then, since y is numbers hours of at second job, then 8y is going to represent how much money I make at my second job. Okay. Together, the money I make at the first job at $10 an hour and the money I make at my second job at $8 an hour is, I need it to be at least 200, so that means it has to be bigger than that. Okay, and that's it. Okay, hope you have a great rest of the day. Bye, guys.